This is the lesson on Einstein's photoelectric effect equation. These are the things you should be able to do at the end of the lesson. Make sure you answer the questions on the quiz at the end. From what Einstein saw experimentally, he used the conservation of energy principle to come up with his equation. So what he saw was that in his metal, he had lots of delocalized electrons. He shone some photons, some light, of different frequency at this bit of metal, and sometimes electrons were emitted, sometimes they weren't. When the photons were very high frequency, he saw electrons being emitted, and as he increased the frequency, the electrons had more kinetic energy, they moved more quickly. If he had a photon that was a low frequency, below a certain frequency called the threshold frequency, we'll look at that in a second, he would get no electrons being emitted. So what he thought about was that the energy coming in was the energy of the photon, and that was E equals hf. E is the energy of the photon, F is the frequency of the photon, and H is Planck constant. And the energy out was the energy you needed to remove the electron from the metal in the first place, the energy needed to emit it for it to become a photoelectron, and the kinetic energy that the electron had once it was emitted. So he said the energy of a photon was equal to the minimum energy needed to remove an electron plus the maximum kinetic energy of the emitted electron. The energy of a photon is E equals hf. The minimum energy needed to remove it is called the work function. That's what we call the work function. And the maximum kinetic energy of the emitted electron was a half mv squared. Now it's called the maximum kinetic energy because the work function is the minimum energy needed to remove an electron. Some electrons would need more than that value of the work function to be emitted. And for those electrons that need more energy to be emitted than what the work function is, they'll have less kinetic energy than this Ke max value. So some key facts for you to learn about the photoelectric effect are that when you increase the intensity, which is the number of photons you shine, you're increasing the number of photons. And as intensity increases, the number of photoelectrons released increases. Because one photon can release one photoelectron, it's a one-to-one interaction. You remember that from when I said that on the simulation video. This does not affect the kinetic energy of the photoelectrons. Intensity has no impact on the kinetic energy of the photoelectrons. Intensity only affects the number of photoelectrons you release. To change the kinetic energy of the photoelectrons, you need to increase the frequency. So as the frequency increases, the number of photoelectrons stays the same, but the maximum kinetic energy of them increases. And this is a graph of what you get if you plot the kinetic energy of the electrons that are emitted against the frequency. And what you will find is that the electrons, the photoelectrons, the electrons that are emitted, have no energy below a certain frequency. That's because you need to have light of a certain frequency or of a certain energy in order to emit your electrons at all in the first place, to give them any energy. And actually, the gradient of that graph is equal to h, is equal to the Planck constant. You could rearrange the Einstein photoelectric effect equation to get Ke equals, and you would see that the gradient of this line would be h. You would have Ke equals hf minus the work function. So h is your gradient there next to f. And your minus the work function, well, there it is down there. It's the y-intercept. So if you were to extend that straight line all the way back, where it crosses the y-axis, that would be the value of the work function.